Hi everybody, it's Guche, and I wanted to give a walkthrough of the M65 debugger I've been working on. And yeah, it's got a few handy perks that I want to share with you. And to begin with, I want to compare it against the raw serial monitor so we can see what that does first and its limitations. So we'll just need a terminal program. In the Windows world, there's Hyperterminal. Linux has Minicom. And Ben mentioned that the Mac world has something called CU, so I'm sure you'll find your equivalent. We can open up your terminal program, and I guess a good command to start with is R, the letter R, 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 and we can see the registers being displayed. We can see the PC is moving about a lot because it's currently a live running system. All the CPU is running at normal speed. And we can press the H, type H, and you'll get a list of raw commands available to you. And some of interest are, let's say, D for dump. So if we were to type D, C00, give it an address, we get a line's worth of byte values. If we wanted a bit more, we can type capital D, C00, and we get a lot more. And let's see a few other commands of interest. G to move the program counter about. M to use the 28-bit address, same as dump. And some of these aren't working, I believe, the S's. B to set a breakpoint, that's quite useful. T for trace mode. This is a bit like putting the CPU in pause. So if I was to type T1, it's like we've paused the CPU. If to prove that, let's type R, 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 and you see it's constantly at the same PC address. So I just type T0 to take it out of that mode, and R, 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 and you see it's moving about now. Okay, that's right, cool, all good. So you can see that's not too bad, but there's a few limitations that we can improve on, and let's do that now. Oh, prior to that, let's have a look at the settings required. If we have a look at the port settings, whatever port your system has for the Nexus board, configure 230,400 bits per second, 8N1 hardware flow control, and that pretty much does it. So in the M65 debugger app, you get those settings by default anyway, so you don't have to configure them. And let's get that underway now. So installing, here we are. We need to do this via Git. In Windows, you're going to need Cygwin. In Linux and Mac, just use your normal terminal. And I'll just open up a Cygwin terminal. You'll need Git installed. Hopefully you've got Git available to you. If not, you should be able to find it via your package installers. Alright, we'll go to a nice location where we can clone this thing. We'll type the git clone command. We'll wait a moment for the source to be retrieved. And here it comes. Take a look, we've got a subfolder now containing the source. Let's go into it. And everything's there. So we just need to type make, and fingers crossed everything will be okay. Here we go, and you should be able to find now that there's a M65 debug binary of some sort. In the Windows world it'll have the exe extension. In Linux and Mac you won't have that extension. And if we were to run it and maybe add this help parameter on it, you'll see it just takes presently one potential parameter for specifying the device. So you might have to have a bit of a hunt around on your system for what your Nexus board serial port device name is. I found it via a bit of trial and error. Serial ports tend to have the TTYS01. For me it was the last one applied, which was 4, and that worked fine for me. I've got a few hints in here. In the Mac world it tends to be something like dev cu.usb serial blah blah blah. I haven't tried it in Linux yet, but I'm going to assume it's going to show up as TTYS something or TTY-USB something. Anyway, let me know one way or the other. So yeah, so basically to run it, you can either do --device or just D and do dev, your device name, and we're in, and that's it. And then you'll see that once we're in, I'm up to here in my help, type help for new commands. Yeah, I'll have to expand the window a bit, or question mark for the old commands. So question mark, we get that list of commands we saw previously. Notice that a lot of these tend to be single letter commands with no spaces between them and the parameters. Whereas you'll see now if we type help for the new commands, a lot of these are, the new command is a multi-character command with a space and then parameter. So let's have a little look around at what we've got. Alright, disassembly. Alright, we've got DIS. Now that's not, well, it's not too bad. But I think this will make more sense with a breakpoint set first. So let's break somewhere. This is my current point of interest, somewhere within the DOS file loading code. I'll type that, and of course it hasn't broken yet. But if I press the restore key on the Commodore for a few seconds and let go, here we go. It's stuck on the command straight after it at E37. So if I was to type this now, it gives me that line's disassembly. So it's taken those raw bytes and figured out the instruction referred to by it, which is okay. Maybe you'd prefer to see a few more instructions afterwards, so just type it as follows and you'll get a few more instructions. Or if you prefer a bit more, you get a few more. Or if you prefer a certain other location, go ahead. And yeah, disassembly pretty much works like that. If I want to break it early, press Ctrl C and you can break it early. That's fine, but I guess, you know, you can see that disassembly just uses raw address values and jumps to raw address values. It might be a little bit handier if we could see actual symbol names here, you know, referenced in the source code and so forth. And so yeah, the next evolution of the app was able to do that. If I just back out of here, in order for this to work, you're going to have to share, like right now we're running it from the present directory as follows, if I can type. But if we were to make a symbolic link to it into a sort of common path area, where is it? It's temp m65dbg, and share that as a symbolic sort of reference, that then we'll be able to run the app from anywhere on your system. I've done that already. As you can see, I've already got one. So now if I was to change the path to where the Mega65 source is located, you'll see inside there are various A65 source code files for the assembly that get compiled. If we were to take a look at them, let's say kickstart.a65, you can see that, I'll go to the beginning. Now this is pretty friendly, you know, we've got comments in here to remind us of what things do, friendly symbol names that we can refer to, and we're jumping to locations with nice symbol names as well. And you know, we've got label names in here. Everything's nice and friendly for us to comprehend. So it would be really nice if we could reference this stuff while we're debugging our code in some way. And so that's what I've aimed at. And we've done so via, you'll see when it gets compiled, these assembly files, they'll generate list files and they'll generate map files. And if we take a look at the list files, kickstart.list, we'll see, okay, here we go. We've got lines of assembled code, and we've also added in the latest Office compiler references to which file this assembled line came from and which line number it referred to. And that way, as the debugger sort of notices that we're on this program counter for this code, it can say, aha, alright, that refers to this source code referred to by this file and this line number. So that's pretty handy. And also we've got the map files. Let's take a look at that. Inside the map files, we'll see there's all the symbol names and the hexadecimal values that they refer to. And they're also available to us within the debugger environment as well. So now that we're in this Mega65 source path with all these list files and map files, if we were to run the I guess the app again. I think it's S4. Notice that this time it runs a little differently. It's telling us it's found and discovered these list and map files for us, and they're available to us. So if we have a look now, we're at this location. If I type disassemble, it looks a little different now. But it's still got some things in common. It's got the disassembled line here, and that was the instruction. But now it's got this big chunk of source code that it's found via that hint inside the list file of this file and at that line number. And you can see that line number has been highlighted here. And you can see, so we know that this store A instruction was store A in DOS file descriptors plus DOS file descriptor after blah 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 blah. So that's a bit more friendlier for us. So yeah, that's a nice perk to have. So next thing, stepping through code. We've got a few instructions there. Step, N, and finish. Step is step into, so it steps over lines, but if it gets to a JSR call, then it will step into the JSR. N is a bit like step, but it's a step over. So if it reaches a JSR jump call, it will do lots of step intos, which can take some time depending on how much work there is to do in the function. So this can run a little bit slow. And then there's the finish command, which is like a step out from. So whatever function we're in, it will just do lots of step intos until that function completes and exits. So we can try a few of those. So if I was to type step. Alright, you can see this isn't terribly attractive. So enter key repeats the last command. So if I press enter, it's another step. And you can see each time it's scrolling underneath what was printed before, which isn't so pleasant. So a nicer way to present this is auto CLS 1. So we get an auto clear screen upon every next command or step command. So if I go step now, we get the clear screen and everything stays in the top of the window. So if I press enter again, yeah, it nicely animates to the next line. It's a bit more readable this way, and we can watch it animate its way through the code. Finish, I guess we don't have a JSR handy, but let's do finish, and we can watch it animate its way out of the function. And yeah, it did. Alright, so that's those three. So we've done step finish. We saw enter key repeats the last. Printing values. Okay, I'll type DIS. Alright, what values do we... Alright, we see a value that might be interesting here. DOS file load address. Maybe we might want to know what that is. So I recall it being a double word. So that's PD. And let's type DOS file load address. And yeah, so we learn it currently equals this value. Maybe there's another symbol that refers to a string. Let's say PS DOS requested file name. And there we go, we can learn what that is. That's quite nifty. And after this, similar to print are watches. So you can imagine as you're stepping through code, let's say I step again, we've lost everything we've printed, and if we wanted it again, we'd have to type it again, and that can get quite tedious if you're following lots of variables. So I've added watches in. So if we, again, we've got the read line library here, so we can use the up and down keys to sort of scroll through our past command history. Read line library also gives us Control R for a reverse search. So maybe if we want to recall what was the last PD command we did, I type PD and it remembers as follows. So instead of this PD command, I'm going to change it to a WD, watch double word of this value. And yeah, it doesn't give me a great deal as yet. So I'll Control R, PS, what was that last string? It was this. I'll change that to a WS. Again, it doesn't show a great deal, but now I can type the word watches, and it gives me the value of both in one hit. So you can see it saves a bit of typing that way. Another advantage is if you were to type auto watch, turn it on with 1. Now if I was to type next, we see the disassembly now has that same watch information automatically added to the top. So this is a great way to keep track of those watched variables as you're stepping through code as well, line by line. And any changes that code makes will get reflected by the variables being displayed there too. So hopefully that'll come in handy. So we've covered watches. Oh, deleting watches. So we've got two references you see at the front here that can be used to delete these. So if I was to type WDEL 1, that would delete the first watch, or 2, that would delete the second watch. So that's fairly easy. And okay, a symbol. If there's ever a time when you're curious as to what was the hexadecimal value of a symbol, you can simply type symbol, let's say DOS sectors red. So we can learn that that was at this address. Okay, that might come in handy on some occasions. There's the save command. Actually, prior to that, I might also, let's say DOS, let's find the symbol address of DOS requested file name. That was at this address. Now if we wanted to check out the byte values of that address, you recall the previous raw dump command. We could dump BC67, and you see the raw dump command only gave sort of byte values like this, which is good. But if you take a look at the new dump command by typing DUMP and BC67, you'll see it's a modest improvement over that. The same byte values, but also character equivalents in the right column as well, which can be handy. And you can also specify another count value, which is in hex, let's say 100 hex worth of bytes onwards, and you can get a bit bigger picture of the bytes in memory. Okay, then there's the save command. Okay, this comes in handy if you want to save a chunk of memory to a local file. Let's say save kernel, which starts from 20,000 in hex and goes for a count of 20,000 hex worth of bytes. And hopefully you'll get some feedback along the way of how the save is progressing. Doesn't seem terribly responsive, but it is saving, I promise you. Yes, I'm getting a few hints of that now. So patience is a virtue, and hopefully it'll be saved soon. Okay, all right, there we go. And the idea behind this was we've recently known about issues with the ROM files being loaded into memory with a bit of corruption, certain areas being corrupted. So this facility can be a way for you to compare what's in memory against what was in the original ROM file. So maybe you've got some sort of comparison tool that you could do in your prompt, command prompt or terminal, and compare the two together, like m65.rom, and then see what those results are and maybe get some ideas on why the problem's happening that way or where to debug it from. Okay, so that's all good. So and backtrace, that was the last command. Maybe I'll just go to some sort of point of interest within a JSR. Alright, let's go into this JSR so the backtrace is a bit more interesting. Step inside. Actually, step inside that one too, why not? And step inside that one too. Alright, now it should get exciting. Alright, so now if we do backtrace. Oh, very nice. Okay, so we've got lots of frames in the backtrace which are telling us the history of calls that got us to this point. So frame 0 is where we are at right now, the load A instruction. And you can see there were a few JSR calls prior to this that got us to where we were. So if we ever wanted to sort of revise how we got to where we were, we can use the up and down commands to jump up and down the backtrace and get these previews going. So if I wanted to go down into frame 1, I'll just type down, and here we go. I've got a little hint here that we're at frame 1, and this is the JSR call that got us to frame 0. So if I wanted to go further down, I type down again, and here we are at frame 2, and this is the JSR call that got us to frame 1. So if I type backtrace again, you'll see that we've got the highlight now on frame 2 because we're presently studying frame 2. So yeah, this is nice and handy. And you'll see most of these are JSR calls, but some of these seem to have garbage values. I'll assume because they're pointing to parts of the stack that have rubbish memory or memory that hasn't been reset since the last time it was used. So it's probably best just to focus on the JSR elements of each frame, and if these, probably the rest of them, just ignore them for now, and maybe one day I should hide them too. But yeah, that's pretty much it. That's covered everything, so I hope it came in handy. And yeah, please let me know if you find my Australian English a bit hard to comprehend, or I'm using any Australian slang or lingo that doesn't make any sense, or my voice is too boring and monotonous. Yeah, I welcome any feedback. Alright, hope it helps. Bye for now.